Okay, this is the second lab for spanning tree protocol. This is the scenario. VLAN 2 is the production VLAN at router R1, switches D1, D2, A1, and testbed. Testbed is a valid switch in this fictionary scenario, whereas switch row should not get connected, but still some user will try connected to the network. For every action item, always verify with show spanning tree interface, or show interface. Okay, let's go with action item number 1. Enable rapid spanning tree with P2P connections. At switches A1, D1, D2, and testbed, make sure that connections are P2P and not shared. Okay, let's do that. Okay, all the ports are shared, so we're going to change them to P2P. Okay, now they are P2P. I'm going to do that at every switch. Okay, that was action item number 1. Let's see, action item number 2. At PC, create a continuous ping to 10.1.1.1, which is router R1. Then at D1, reset the interface that goes to the router. Measure the time until the ping becomes successful. Okay, let's see. Okay, we're gonna create a ping here. Now, at D1, I'm gonna have to go to interface D10, shut down. Okay, now I must set up chronometer. Okay, I'm going to bring the interface back up and see what's happened. Now shut down. Let's see what's the time it takes. This trunk is not configured with PortFast yet, so it is going to take about 30 seconds. Okay, it was 30 seconds. We're going to configure now PortFast. We're going to do the same test again. The ping is off, and I'm going to restore the interface and see what happens. As you see, the interface comes back up immediately. Okay, let's see the next action item. Number 3. At switch A1, configure gigabit 11 as PortFast with BPDUGuard, the connection to PC1. Okay, let's see. Okay, let's see how the trunk was shown in a spanning tree. Okay, this is the trunk. And if I do a show spanning tree interface G10, it shows up like this. Okay, I could also do a detail. PortFast Edge trunk mode. Now let's see how it's shown for an access port. Edge. Show spanning tree interface gigabit 11. Okay. PortFast Edge mode. BPDUGuard is enabled. Okay. Next item. Item number 3. Number 4. Action item number 4. At switch A1, configure gigabit 12 as PortFast with BPDUGuard. This is the connection to row switch. Okay. Let's see. Okay, next, at row switch, enable gigabits 01. This simulates the connection is of a non-allowed switch to the port. Observe gigabit 12 start. Okay, let's go to the row switch and let's enable interface 01. Now shut down. Let's see what happens. Okay, this makes BPDUGuard to kicks in, and BPDUGuard will disable the port. So show interface G1 to ErrDisabled mode. So BPDUGuard kicked in and placed this port into ErrDisabled mode. Let's see. Show spanning tree is not showing the port because the port is in ErrDisabled mode. Okay, great. Next action item. Number 5. At switch testbed, enable gigabit 01, observe the port status, figure out what the problem is, then fix it. Okay, let's go to testbed. Let's configure G01. Now shut down. Okay, let's return to A1. Okay, inconsistent port type. See, show spanning tree. Type inconsistent. Show spanning tree interface G13 detail is broken, inconsistent type. let's see, E13 switch port. It is operating in access mode, whereas testbed is in trunk mode. So that is the source of the problem. So let's go back here and configure that port. Strong. So the error went away. Okay, it is forwarding now. Great. Next action item. Number 6. Then configure switch testbed as root primary for VLAN 2. This simulates the scenario where a switch that is not supposed to be a root bridge tries to become a root bridge. Okay, let's go back to testbed. Oh, I have to configure here RootGuard. So show spanning tree etc 13 detail RootGuard enabled in G13. So let's go to testbed and simulate that by mistake. This one wants to become root primary. See what's happening. A RootGuard kicks in and we'll place the port, let's see in what mode. Spanning tree, root inconsistent mode. Is broken, root inconsistent mode. Okay, great. Next action item. LoopGuard, number 7. At switch A1, validate that G01 is root and G02 is alternate. Then configure them with LoopGuard. Let's see. Okay, G01 is root, G02 is alternate. Let's configure it with LoopGuard. Here is 23. It's G02 detail. LoopGuard. Okay, that wasn't show up. Okay, I was validating that with show spanning tree. I validate that G01 is root, G02 is alternate. Then I configure spanning tree LoopGuard. Then with this command, I can see that LoopGuard is enabled to the port. Okay. At D2 simulates a fiber connection failure by disabling G01. This emulation does not detect remote switch interface shutdown. So the interface G02 and A1 will remain up, while the interface G01 at switch D1 will be down. This simulates a fiber strand cut between D2 and A1. Okay, so let's go to D2. And simulate a fiber cut. Interface gigabit 01. Shut down and see what happens. A1. LoopGuard kicks in and puts the interface gigabit 02 on loopback blocking, show spanning tree, loop inconsistent mode, interface gigabit 302, tail, loop inconsistent mode. Okay, that's it.